In the second video in this series, we're going to look at velocity and how it relates to displacement. So we're going to look at these 4 points. The first is velocity is change in position over time. This we already know. That means that the change in position determines the sign of the velocity. That is to say, if the displacement change in position is negative, then velocity is negative, and change in position is positive, then velocity is positive. Third thing, the slope of displacement versus time graph is the same as tan theta, which is the same as velocity. This we will look at. And the fourth is what is basically positive and negative velocity. Let's begin. Okay, let's take the case of this graph. We find an object. As time proceeds, the object seems to be moving in a positive direction. If you remember our previous video, as time proceeds, our object is moving in a positive direction. Let us try and see the velocity between these 2 points. Now, if you remember, velocity is given by displacement, that is change in position over change in time. So this is the t final, t initial. So change in time will be t final minus t initial, and the change in position will be, this is the final position and this is the initial position, so it will be p final minus p initial. If we look at this in fact as a triangle, what you realize is it is nothing but the perpendicular upon the base, and interestingly the velocity therefore is the slope of this line, tan theta. The slope of this line gives us the velocity. Okay, so in this case, what we find is delta p, p final minus p initial, is a positive value, and therefore this slope has a positive value. Therefore, this velocity also has a positive value. Let us look at the second case. In the second case, let us take, as time proceeds, we find that the object is moving towards zero. If you remember this means that we start off with a positive value and we move towards zero. Start off with a positive value and move towards zero. In this case, what we have is, in this case, what we find is, this is the final time, tf, and this is the final position, and this is the initial time, and this is the initial position. So if we look at velocity in this case as delta p, p final minus p initial, it is clear that since p final is smaller and p initial is larger, this value will be a negative value, that is, it's less than 0. This value, of course, is all t final minus t initial is always positive, and therefore what we get is, in this case, you can omit this. In this case, we find this kind of a slope is called a negative slope, and the velocity in this case is said to be negative. Okay, so this is the idea of negative velocity and positive velocity. A third case is one where the object is stationary, that is, with change in time there is no change in position, the position remains constant. P final minus P initial is equal to 0, and therefore the slope is equal to 0, the velocity is equal to 0.